AI Plus Club Unilag Virtual Bootcamp, and this is the Getting Started with Machine Learning series. Here we'll be learning the core concepts of machine learning, artificial intelligence, deep learning, data science. Basically, we'll be looking at demystifying the what and what not around building a model in machine learning, an overview of machine learning algorithms, evaluation metrics with machine learning, the types of machine learning algorithms, and we'll be helping you kickstart your career in data science and machine learning. So about me, I'm human and I'm Nigerian. My name is Victor Irepono. I study urban planning at University of Lagos. I also work as a deep learning engineer at Retina AI Health, which is a US-based healthcare tech company that builds cutting-edge artificial intelligence software for healthcare diagnosis. I play with geospatial analytics, GIS, and their intersection with big data and AI. I was lead Python instructor at Developer Students Club, University of Lagos. I've also done a couple of research on Twitter big data mining. I'm a polyglot generalist programmer. I code in multiple languages. I've also won series of competitions. I emerged as first place winner at the Access Bank Data Hackathon last year together with my team. And more recently, my team and I at the Pan-African Intercampus Machine Learning Competition organized by Zindi Africa became first in Nigeria and third in Africa. Fun fact, I love plantain, especially when it's fried. You can connect with me via my social media handles on Twitter at Irepono Victor, on Instagram at Victor Irepono, LinkedIn and Facebook I'm Victor E. Irepono. Good. Now, so we'll be covering the core concept of machine learning, what machine learning actually do, why we need machine learning or artificial intelligence. We'll also be looking at the types of machine learning algorithms. We'll also be taking an overview of some machine learning algorithms, and we'll be looking at some machine learning model performance evaluation metrics. So what really is machine learning? Machine learning is that branch of artificial intelligence that allows computers to be able to do stuff or do programmable tasks without being explicitly programmed to do so. So just take that from me to you. That is a computer doing stuff that you didn't explicitly write in code for it to do it. So that is what machine learning is. Now, as I said earlier from the previous slide, machine learning is a subset of artificial intelligence. So take a look at it from the concept of machine learning, of artificial intelligence being a big umbrella. Then you have machine learning as a subset of that umbrella. So there are other subsets, there are other components of artificial intelligence aside machine learning. You have robotics, we have natural language processing, we have perceptron, we have cognitive systems, neural networks. They are all subsets of artificial intelligence. Now, why do we actually need machine learning? What does machine learning actually do? Now, we need machine learning to automate stuff, to make things go autonomously. We need machine learning to make machines do stuff without being explicitly programmed to do so from the definition. For example, your spam detector in your Google Mail automatically classifies mails as spam without Google explicitly coding it out that, okay, if the mail contains this word, if the mail contains that word, if the mail contains so and so word, mark it as spam. What they did was they just trained a model of spam versus not spam, and then so anytime a mail comes in, it runs that mail through the model and then decides if that mail is a spam or not a spam, if it's a spam or not a spam. Yeah. So basically, the way we're doing that, we've basically automated the process. Rather than writing codes to do that, we've learned an algorithm to do that for us. But then you might want to ask, but you can actually automate stuff with your programming. You can actually write code to help you download news. You can actually write code. There's what we call create, read, update, and delete CRUD apps. You can actually build CRUD apps that does stuff automatically without using machine learning. But then the answer to that will be machine learning evolved because some tasks were too computationally intractable to do. What I mean by that is that the tasks were dimensionally too wide, so you can't come and start coding it out. For instance, like a text-to-speech generator or an image detection algorithm or a facial detection algorithm. I don't know how any programmer would want to code out or write code to be able to differentiate one face from another, and the code will be efficient. No, the code will never be efficient. But you can easily train a machine learning algorithm in less than 2 hours, and basically the algorithm is going to be able to detect faces and also differentiate faces. So the classical way of programming, which is what I described earlier, you explicitly writing codes to do stuff, is not sufficient, and we'll see the reasons why in the following slides. Okay, so now let's take a deep look at the classical way of programming. Now, in the classical way of programming, you would normally have a problem. Then you would also have rules. You come up with rules or an algorithm to solve that problem. Then you know what algorithms are, steps. Then you put those steps into code, you write code to solve those steps, and then voila, you have your solution. But then such methods are not really that efficient. We will see the reason why they are not efficient and why we need machine learning in the following slides. So example of processes that requires classical way of programming, rule-based processes. Examples of those tasks or problems could be: you want to build a mobile app, you want to build a game, you want to build a website, you want to build a desktop application, etc., etc. Now, so as I was saying, the classical approach is not really that efficient in doing some certain kind of tasks, because let's say you want to train you want to create a classifier, a cat versus dog classifier. So how would you write code to differentiate between a cat and a dog? I'm also trying to imagine that myself, and the dimensionality of the task is way too large. One would not be able to finish that in months, even if you have a whole team. And the funny thing is, your code is going to be inefficient. It will fail at some point. But you can easily train a machine learning algorithm, feed it images of cats, feed it images of dogs, let it look at those images over and over and over and over again. It will get to a point whereby there is no image of cats. You show the machine learning algorithm that it won't be able to detect. Don't worry, it may seem vague now, but as you progress more and more into machine learning, all these things will become clearer. So in tasks like that, classical approach to programming fails. For example, let's take also as image and speech recognition, text to speech, text translation. Okay, let's even look at Google Translate. Imagine if you as a programmer, okay, you taking this course, you must have had some idea about programming. Just for instance, let's just imagine you want to manually, or you want to hard code text to speeches. Like, you say a word and the computer is going to like read that thing out. Or you want to do text generation. Just try to imagine the amount of code you have to write to do that. I'm shivering in fear already. But with machine learning algorithms, specifically transformers, we will be able to do that easily. In hours, you will have your machine learning algorithm helping you to do those tasks already. Now, so machine learning is required in tasks and processes where the dimensionality is high, when you have so much big data. And mind you, machine learning will only excel when you have so much data, big data, like data in millions, hundreds, and thousands of columns, of rows rather. So it's in this kind of task that classical approach fails. Now, so we'll be looking at machine learning. As I said earlier, in order to train a cat versus dog classifier, or to do a text-to-speech generation, or to do some natural language processing tasks, will be somewhat impossible if you are trying to hard code it. Your code will be so much error prone. Like, there will be so much errors with your code, and your code will most definitely fail at some point. But with machine learning algorithms, everything works seamlessly. When you have your problem, you have your data set, you feed your data set to your algorithm, you train an alarm, you have your output. So now, if you notice, we are able to read text, you are able to listen to me, you are able to read these slides, but you don't really know how your brain does it. And these are all neural network operations that we'll see later on in the course of this lecture. So now, with machine learning data sets, the nature of the data set is quite large. Dimensionality is high, so it's very, very hard for you to use rule-based method to figure it out. It's best to let the algorithm look at the data and learn the underlying distributions of the data, and it gives you an output. To be best if things work that way. So now we've looked at classical approach to programming and solving tasks, and we've looked at the machine learning approach. So we can now come up with some new concepts. We can now say machine learning is definitely and basically an automated approach whereby the computer analyzes data and generates certain patterns, looks at your data and okay, these are some certain patterns, these are some clusters, these are some aspect of these are some patterns basically of your data set. So now the difference between machine learning and classical programming is that with machine learning algorithms understands the pattern. It figures out the patterns of the data set on its own without being explicitly programmed to do so. But with rule-based, that is the classical approach, you have to manually write out some rules. That's where you have series of if and else, 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 and so on and so forth. Now, so this whole process makes it possible for the machine learning algorithm to run smoothly. Okay, I was going to give another instance of using that same cat versus dog classifier. So what happens is you pass images of cats and images of dogs into a machine learning algorithm. So you pass there's what we call epoch in machine learning. So epoch is the amount of times the machine learning model sees a particular image in a data set. So you passing images of cat, you showing images of cat and dogs to a machine learning algorithms maybe 1,000 times or 2,000 times, depending on how many epochs you want. You showing a machine learning algorithm such images of data set. You get to a point, it will be able to determine, okay, this image is actually a cat and this image is actually a dog. You won't tell it that, okay, if it has 4 legs or if it has this color or if it has a teeth or if it has a ear, you won't need to tell it that. Whereas in the classical approach, you have to explicitly write that in code. I don't know if you are getting the whole buzz about machine learning and the difference between machine learning and the classical approach and why you should use machine learning over classical approaches. Although it's not supposed to be an argument, I just want you to counter the fact that you can also use a classical approach to automate stuff. So there are stages to this automation. So to reiterate, you should only use machine learning only when classical approach fails, or when classical approach works but is computationally intractable. For instance, see that spam versus not spam detector or classification. You could also use a classical approach. You could also hard code it, but then it will be computationally intractable. So it's best you just let a machine learning algorithm do its job and you sit back and relax. Now there are several products that make use of machine learning. Machine learning is so much diverse. It cuts across all fields, cuts across all professions. So I don't see any reason why everybody should be jumping on machine learning. Machine learning is the future, according to me. Come and change my mind. So with facial recognition, you use machine learning. Autonomous and self-driving cars make use of machine learning and LiDAR images. Predictive policing also makes use of machine learning too. For example, in cases where you have gang violence, you can train a machine learning model to predict when next a crime is going to occur and then act accordingly. Then also we can also use machine learning for optical character recognition. and also is widely used in recommendation engines. YouTube, especially Netflix, Amazon, SoundCloud, they all use these machine learning algorithms recommended for their recommendation engines. Even Apple Music, our recommendation engine works is that they just look at your interest, the songs or the music you've listened to, or the movies you've watched. Then they bring out movies that are similar to those movies that you might like. And then when you see it, you'll be like, wow, okay, this is similar. It's kind of related to the one I just finished watching. Let me watch it. So it's just a recommendation engine, and this thing works autonomously. Nobody is coming to, okay, Yemi, Yemi just watch this movie. Then the program will come and say, anytime Yemi watches this movie, blah 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 blah. No, it doesn't work that way. It works autonomously. So now this is a simple spam detection algorithm. This is our product that uses machine learning. As I said earlier, when your email comes into your phone or your laptop, it passes through a machine learning algorithm first. So that algorithm now reads the contents of the email and determine if the email is spam and if it's not spam, based on the model that Google Mail has trained already. So it's basically application of machine learning. We'll be seeing several other products that uses machine learning. So product recommendation is also a very big application of machine learning. Netflix uses it, Amazon uses it, YouTube uses it, even Apple Music uses it. Yet when you finish listening to a song, they recommend, okay, hey Victor, you might like this. Based on what you've listened to, you might also like this. So that's how it works. And also with facial detection, Facebook is big on this facial detection. They have all our data, so they are able to train very good and accurate facial detection algorithms. Recently, I was trying to upload a picture on Facebook, and you won't believe the Facebook algorithm identified everybody in the picture. Like I just had to click and click on the person's name. So everything is now getting automated, and everything is powered by machine learning. And here in medical treatment and diagnosis, this is also another powerful area where machine learning works. For example, I work with Retina AI. We build cutting-edge artificial intelligence for healthcare diagnosis. We have a fluid intelligence software that can detect diabetic retinopathy in your retina. There are also several applications of medical treatment that uses machine learning. You have MRI scans, you have IBM Watson Genomics, you have Google DeepMind, you have CareScore, and so on and so forth. So how a standard approach of how machine learning would find good use case in medical treatment and diagnosis could be in the aspect of medical imaging. So instead of having a medical doctor look at, or an ophthalmologist look at retinal images and say, okay, this image has retinopathy, this image has neovascularization, this image has macular edema, and so on and so forth. You could train a machine learning algorithm that understands when an image has retinopathy and when an image does not have retinopathy, and the grades of diabetic retinopathy in each image. So forgive me for nerding out, is basically what I do every day. So basically you have a machine learning algorithm do this stuff for you, and what you have to do is just validate it, and you discover that these machine learning algorithms are almost as accurate as the human graders. So machine learning algorithms has come to stay. So it's something everybody should want to learn and want to jump on, basically. Yeah, and also in customer segmentation models. So say you have a customer data based on age and income. You could segment your customers into different classes or different clusters. You could have retirees, you could have soccer moms, students, executive, etc. based on the age and their income. So for instance, if you look at this graph you have on the right, where I'm moving my mouse, you have the retirees. If you notice that almost at the end of the curve based on the age. So you know that, okay, yes, people that are within this age are clustered together as retirees. Then also look at the students, the age is still closer to 0. So you know, okay, people that are still young are usually students, and also think of where the income is. They don't really make that much income. And the executives makes the most income. So you can use it to like segment your data and get accurate, good, insightful business information from your data set. So AI finds good applications in in data segmentation. So this whole process basically is called segmentation, customer segmentation. MTN does it. Most fintech institution does it. So it's something you would want to add to your skill set, and machine learning makes this possible. Now we'll be looking at types of machine learning algorithms. Now, so machine learning algorithms is subdivided into supervised learning algorithms, unsupervised learning algorithms, and reinforcement learning algorithms. So with supervised learning algorithms, you have your in your data set, you have your training images, and you also have your target labels. So you are passing your training images and your target labels into your machine learning algorithm. Let me come again. So with supervised learning algorithm, you are passing your image, your features, and your labels into a machine learning algorithm. So the machine learning algorithm predicts based on the image and features you passed into the algorithm earlier. But with unsupervised learning algorithm, you are not passing in any labels. It's just your training data. So you expect the algorithm to be able to learn underlying features in the data set on its own. So you could either cluster the data set or use some dimensionality reduction, or probably generate new samples from the latest space, or whatever you want it to do basically. So supervised learning, unsupervised learning, and reinforcement learning. Reinforcement learning is basically action based, a reward system whereby whereby your model is learning from mistakes. For example, the game of Go, the game of chess. So you have a machine learning algorithm play against itself millions, in fact, quadrillions of times. So it learns from your mistakes, it optimizes, it penalizes itself when it makes an error, and optimizes for that. So the back and forth process of the machine learning from its own self makes it better. In general, in life, one of my friends will say life itself is a very good example of reinforcement learning, because in life you are meant to learn from mistakes. If you don't learn from your mistake, you learn from other people's mistakes. So basically you learn from your mistake, you adjust your weights, and then you repropagate again basically. So supervised learning algorithm is subdivided into classification and regression problems. If unsupervised, you have clustering, you have dimensionality reduction, you have generation, etc. So we'll be zooming in on each of the type of machine learning algorithms. I hope the topic of the lecture has been very, very insightful so far. I hope I'm not I hope I'm not being too fast. All right, now, so with supervised learning, we have, as I said earlier, it's subdivided into classification and regression problem. So now classification means to, okay, so with classification you are trying to determine what class a particular data point belongs to. So with classification, the labels are discrete, but with regression the labels are continuous. Okay, so that is me juxtaposing between classification problems and regression problems. So classification problems, basically one way you can identify a data set that requires a classification algorithm is that the labels are very, very discrete. So they are finite. So they could be 1,000, it could be 2,000, it could be as much as that, but you won't see such data. So the highest I've worked with is 137 at the Humaja hackathons, the last hackathon I competed on. But most likely they are between 2 and 10. That is binary classification, and maybe 10. Most likely your data set will be between 2 and 10, but it could vary. But just know that it's discrete. But with regression, is continuous. There is no end to what you could get. So an example of problems that will require a classification algorithm could be like a survivor versus no survivor. That is a binary classification, or what you might call it, a survivor versus no, like a Titanic problem whereby somebody survives, somebody doesn't survive, an employment promotion algorithm whereby you have to determine if an employer or an employee is to be promoted or not promoted. There are several use cases, so just have it at the back of your mind that with classification algorithms, the target variable, what you're supposed to predict, is finite. You get, but with regression is infinite. It's discrete, and with regression is continuous. So let's look at the graph that we have here. So here you can see it's a binary classification under classification, whereby you have to juxtapose between a bear and a bull. So this should be an image classification problem, where just like the cat versus dog, you just feed in images of a bull versus bear into the machine learning algorithm and let nature take its course. Don't mind me. And let the machine learning algorithm do its job and then produce the output for you. Same thing with regression. When you are working with probably housing prices data, you are talking about regression problem. When you are working with income, you are talking about regression problem. When you are working with stock data, you are talking about regression problems. So if it's a real number and if it's continuous, then it's a regression problem basically. And if it's a discrete or categorical variable, then it's a classification problem. So to sum it up, with supervised learning, the target variable is known. Now with unsupervised learning, the target variable is not known. So there's no target variable. You get. So you just passing your training data to your machine learning algorithm and expect your algorithm to understand the underlying features or the underlying what shall I call it? To understand the underlying structure of your data. So looking at the graph we have here below, we have about 5 clusters from cluster 0 to 4, and each cluster have different colors. So probably they were clustered based on their color. So if you notice, things that are similar are clustered together, while dissimilar data points are separated, they are not clustered together. Same thing with dimensionality reduction. So basically, dimensionality reduction is reducing the feature set, reducing the dimensions into a lower dimension without losing much data, such that you can also reconstruct whatever you've encoded without losing much data also. So my favorite dimensionality reduction algorithm is the autoencoder. We'll get to that subsequently. So, but for now, I just want to keep things very simple. We won't be going into code. We just want to build the intuition on machine learning, understand why you should use machine learning, understand when machine learning works over classical programming, understand the types of machine learning algorithms, and just follow along and you will get the gist of it. So now, with reinforcement learning, you are talking about how to achieve or how to attain a complex goal or maximize a particular dimension over many steps. For example, like I explained earlier, in a game of chess, Go, or Space Invaders, where an algorithm plays against itself several countless billions of times till it becomes better and perfect at it. So also investing in the stock market requires reinforcement learning algorithms, a reinforcement learning type of problem, and making fast food, in fact life itself, as my friend would say, is a reinforcement problem. Now, so we're looking at an overview of some machine learning models. At this juncture, we've talked about machine learning algorithm. We've talked about types of machine learning algorithms. We've talked about machine learning itself. We've looked at classical programming and why you should actually use machine learning. You've defined machine learning. That is going from back to forward. Now we are going to be looking at an overview of some machine learning models. Now, before we move forward, I want to explain the no free lunch theorem. I saw this on Cargo and I thought everybody should come across this. Okay, so the no free lunch theorem states that no one algorithm works best for every problem. What this simply means is that you should pick an algorithm based on the problem you have, and also you should pick an algorithm based on the data set. It will be very, very unwise and unprofessional to use a classification algorithm for a clustering problem, for an unsupervised learning problem. To use a classification algorithm to cluster data set, it will be very, very unwise to do that. So you have to understand the problem you want to solve, understand the data set, and then you pick your algorithm accordingly. It's not hard. It's not rocket science. So we'll be looking at some supervised learning algorithms. Yeah, then we'll be looking at linear regression. So linear regression is a supervised learning algorithm that falls under the regression problem task. So where you want to predict an housing prices, you want to predict employment, you want to predict income level rather, you need it's a regression problem, so you need a regression algorithm. And linear regression is the most basic regression algorithm, very powerful. It's a parametric method. So linear regression finds a line of best fits, a line that best fits the relationship between the input variables x and the output variables y by finding specific weights called coefficients. So essentially, you are trying to find the line of best fit, a line that best fits across the data set, and you are optimizing for that. Now, logistic regression is, forget about the name regression, it confused me too when I newly entered machine learning. But logistic regression is the go-to classification method for binary classification. That is when you have just two classes. So with linear regression works for regression, logistic regression works for classification problem. So where you have a sigmoidal function that helps to juxtapose between the two classes. Basically, that's how logistic regression works. So other popular supervised learning algorithms that are state of the art includes decision trees, random forest, bootstrap, aggregation, bagging, XGBoost, LightGBM, CatBoost. Now, so with decision trees, also known as classification and regression trees, they are used for both classification and regression tasks. So you know what a decision tree is more like at each tree and at each node, we are picking options in order to get to your final objective. So you are picking if it's a yes or if it's a no, if it's a one or if it's a zero, either a one hot value or a yes or no value. So that is how it is till you get to your goal. Now, random forest is basically a collection of decision trees. Then you also have your bootstrap, aggregation, your bagging, and you have your XGBoost, which is state of the art. You have LightGBM, and also you have your CatBoost. Now, these are state of the art models that can be used for regression and classification algorithms. I won't be going too deep into all this for now. We'll be looking at them subsequently later on. Now, some unsupervised machine learning algorithms include k-means, principal component analysis, generative models, linear discriminant analysis, and so on and so forth. These are just some of the state-of-the-art unsupervised learning algorithms. So k-means algorithm is used for clustering. When you have data points in your data set that you want to cluster, you want to find the underlying distribution. For example, like that customer segmentation model we saw earlier, k-means algorithm can be used for such kind of clustering. One real life example that I remember doing. Remember one of the hackathons I won, the one we did at Access Bank. We employed k-means clustering to identify customers that will default. Basically, when they collect loan, which is basically a non-performing loan program. So we use k-means algorithm to identify customers that would fall into the category of those that will default whenever they come and take loans. So that served as an advisory or insight to the bank that okay, customers that fall into this class would normally are prone to default, are more likely to default. Then with principal component analysis, we are trying to reduce the dimensionality of the data set. And with generative models, you are trying to generate samples given your data. So these are some more advanced concepts that we'll be looking at later on, but we'll start from the supervised learning algorithms first before we move to unsupervised learning algorithms. Evaluating model performance in machine learning. Different machine learning algorithms. So this works for supervised machine learning algorithms. And remember, in supervised learning algorithms, we have classification problems, we also have regression problems. So classification problems have their evaluation performance, their evaluation metrics. Regression problems also have their evaluation metrics. So in classification tasks, we use accuracy as the evaluation metric. We could also use classification report as the evaluation metric. We could also use our completion matrix, classification report that shows the sensitivity, the specificity, the positive predictive value, true positive rate, negative predictive value, false positive, false negative, true positive, true negative, and confusion matrix that is just a one hot of the true values and the model predicted values. So we'll be looking at this later on fully. What I'm just trying to do is I'm just trying to build an intuition, just something simple. You just understand the basic concept of machine learning. Then when we get to the hard part, we won't have to be going back and forth. So we won't be looking at code in this lecture, probably basically because of the time and just because what I'm after is just to build the intuition. So that's why I'm trying to make everything as simple as possible. But with regression problems, on the other hand, we use mean absolute error. We also use mean squared error. Then we use the R squared error. Then we use the root of the mean squared error called the RMSE. So you are most likely during training time you have to optimize for these errors. And it is worthy to know that all these evaluation metrics can all be implemented in scikit-learn. If you are familiar with scikit-learn is basically a Python machine learning library. Actually my favorite machine learning library. Don't worry, we'll get to that. So basically, a summary of this lecture is what you should have learned, what I expect you to know based on what I've talked about in this lecture. I expect you to understand machine learning now. I expect you to be able to defend machine learning anywhere to everyone and anywhere. I expect you to know why we use machine learning over classical algorithms, over classical problem solving algorithms or classical programming. I expect you to understand why we pick machine learning over that. I expect you to know tasks, the use cases whereby machine learning will excel, and the use cases whereby classical programming would excel. I also expect you to have at the back of your mind the different products that use machine learning, different products that use machine learning, and the different use cases of machine learning. And I also expect you to know the types of machine learning algorithms. I expect you to know the branches of machine learning, supervised. Okay, let me not. I expect you to know that. I also expect you to have an overview of the model evaluation and performance metrics. So with this, at this juncture, I want to bring these slides. I want to bring this lecture to an end.